Uh, let's begin. Welcome to How I Crashed R and what you can do to minimize the blow. Pretty much, I have crashed. Oh, I'm realizing that I don't know how to advance the slides, but there we go. I'm just like you. I started out with my intro to BA 6356, like everyone else. I learned clustering, association rules, I learned everything. And then afterwards, we had these group projects, everything was wonderful. I had this wonderful feeling after my class, which I'm not sure differs from class to class, that the world was my oyster. That I had all this data out there that I could go and figure it out, and I could go and try to predict the world. Yeah, you're gonna see what really happened. But basically, I'm here to save you time because I almost blew up my computer. I crashed a bunch, and I crashed some more, and then I have nights of suffering and drinking energy drinks and just these sorts of things, right? So basically, I'm going to tell you about those things so that you don't have to go through them. So it's easier for you. Some of the things that didn't teach me were global options and importing data. Ultimately, normally when you go to classes, they give you pretty good data. They just give you pretty good data. And so one of the things that you really run into at least once from every new person is stringus factors. So what is stringus factors? The default option for stringus factors is it is on. It is true. Now what that means is that if you pull something in from a data set, it's going to be low, high. If that's something that's a text, right? Some kind of string, right? Something that's text that, well, the computer really doesn't know what to do with, right? It would normally be considered a character string or something. R was built a long time ago. R was built by statisticians. Anytime they were going to import something, normally, if it was a character, it was going to get shoved in as a factor because it was going to be something like high, low. It's going to be something like yes, no, right? And so, basically, the default was yes. But now we do a lot of other things. We do a lot of other things with R. So this becomes sometimes more of a hindrance than a helper, right? So depending on what you're doing with it, once you really know your data set, then you can sort of really figure out which one you want. But when you're first starting out, this is more of a hindrance than you really want. If you want to convert it into a factor, use something like factor or as factor to convert your own columns, right? But when you're importing data, I would suggest you start off with options, which is a global option, meaning anything else you import afterwards, it's stringus factors equals false. It helps a lot. But you can also do it as a data frame. I showed you up there. Also, and so not up there, so, a function called fread also has the default as stringus factors is false, right? It helps a lot. I have struggled a lot with it in my days. I can actually show you. I had a little demo shown. I don't know if we're going to show that, but if we do, we do. We don't. That's fine. But basically, converting it from a factor to anything else can be trouble and problematic. So you sit there and you're like, I can't, and you suffer and you cry and you look it up online and then you cry some more because you can't get it to work correctly. So if you just do the pre-processing up front, you're going to save yourself some time. These are some other options I use. Options digits equals number, a number that you choose, right? Which means that after the period, so if it's 1.10, 1.10, right? And you say digit 1, I'm sorry, that's a bad example. If I said 1.11 and I say the digit's 1, I only want one digit, it means it's only going to print 1.1. Instead, it's going to cut off that last one, right? So, why do I care? Well, if I'm looking at a whole data frame of data, I sometimes want it to be standardized. I don't want to see one thing that has 20 dots, a period, and then 20 digits, and then with a sea of a bunch of other ones that are like thousands of times bigger. I don't care. I want to see it relatively standardized. So digits helps. Same thing with SciPen, because I go 10, 10, 10, 10 to the E. Wait, I got to make sure, is it negative, is it positive? Is it really big or is it really small, really, right? And then so it's hard for me to then look at all the data and really make sense of it. So if you turn off SciPen, which is scientific notation, it basically will show you how big the actual pieces of how big the actual data is, right? So if it's 0 or near 0, it will basically become 0, right? And if it's really big, unfortunately, you're going to see the really big number. But the good thing about that is that you'll see it, and then you'll be like, something's wrong with that one, right? Instead of it going 10 to the E to 10, and you're like, all right, if you're looking at a sea of data, you may not notice. MaxPrint something also I use, but I use it more as an exploratory thing. Basically what it does is when you print something out, or when you hit enter, right, and it shows things in the console, there's a certain maximum level that pops up, right? Usually it's set to like 99,000. What is all there is a default. I have the default down there. It's huge, right? So it'll print a whole like essay of things. And sometimes I don't care. I want to see just the top, or I just want to see a little bit. And I don't want to keep typing in head, if you don't know what head is. Head just shows you the little, I don't remember how many lines, but a certain top portion of the line, of the data frame. Tail shows the bottom portion of it, right? So you can sort of do that, but I don't want to keep typing that in. And I don't want to keep typing view. It's all a pain in the butt. So if I'm exploring the data, and I want to look at everything, and I want to look at things quickly, sometimes I'll do max.print, right? Because I want to look at it, and I want to just type it in, hit enter, show it to me, next, right? Next, 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 instead of going view or head, and I gotta keep typing these things, right? So there's a little bit of a warning. You gotta watch out for this, because some of the functions that internally they use the print function, and so if you set the limit too low and it prints out, it may not put all your data into the next thing, and it might not actually work. So you gotta set it back to the default once you're actually doing analysis and calculations, right? This is more, for me, what I use it for is just as an exploratory, right? So exploratory setting. That's the one I'm a little bit more worried about. Number is, of course, just you put your number, right? Put a number that you feel comfortable with, you can play around with it. It's really not that difficult. What you're really here for. You're here because I crashed. I crashed a lot. Not cars. I don't crash cars. But if you look at over there, you can see there's a giant white screen. And you can see lots of white screens. So these are all what I consider crashes, right? I crashed a lot. I used to send pictures to my friend. Like, hey, I crashed it. It's like, again, it's like computer exploded. Great. So what I've determined is that there's three types of crashes. Now unfortunately, this is for Windows machines, right? The first is the mini crash. Basically, it just means it's slow, and you don't know why it's slow. I'll tell you how I figured this one out, by the way. Second one is a screen crash, which means that you see the screen. Actually, if you see it's in the middle one, you see the screen. However, you can't do anything. You can't save. I mean, you can type code, but you can't save. So why type code, right? And you can't. It just continuously runs. You have that little red button. So I don't know if you can really see the little red button. That red button means it's running, right? And it just sits there. And then my favorite one, it's the white screen. What I call Christmas. It's dreams of Christmas, right? Because it's white, and everybody wants a white Christmas. So I'm gonna go into a little bit more detail. I'm gonna go into a couple of my stories. The mini crash. Now, how did I know it was a crash? How did I know it crashed? Well, I had a friend. I'm sorry, I still have a friend. He's still my friend. I have a friend, and I shared with him my code, right? I shared the code with him. That was really bad English. I shared the code with him, and then we ran it. I had a desktop, 12 cores, 32 gigs of RAM. Whoa, awesome. He has a little laptop. It's a little newer than mine, but lower amounts of RAM, lower processing power. We ran the code at the same time. We shared each other's screen, and I looked at him, and I went, he's like, yeah, I'm done. I'm like, I'm still running. And I was like, what? So I was like, just to make sure I'm not crazy, let's run the same thing. Run the same thing. His finished in like 5 seconds. Mine finished in like a minute. And I was like, what is going on? What is going on? Now the problem is really determining when this has happened, right? Normally what happens is that R gets a little bogged down, right? So the way that I've figured out how to fix this is you use, well, I'll show you in the next one. But basically what I'm saying is, in this slide is, you're not crazy. Sometimes it's just slow. If you come out from a hibernation or a sleep, you also want to do this because generally your RStudio will just, I don't know, have a cow. Basically things are probably in your disk drive and it hasn't shoved back into RAM, right? So this is how you generally resolve it. help diagnosis reload UI, right? If you do that, it'll reset, and generally it'll come back. The other way that doesn't really hurt that much is if you use what's called garbage cleanup, which is GC and then the little parentheses, right? It's basically at that point, it really actually cleans up anything that was outside, anything that you actually deleted, right? So if you use the RM command, which RM is remove, right? RM and then again brackets, right? And you remove something, right? Sometimes it doesn't actually really remove it. I mean, it doesn't show up in your environment anymore, which is on the upper right. It doesn't show up in there anymore, but still sometimes keeps it there, right? So GC actually clears it away from memory. This becomes more useful because, well, we deal with sometimes in Data Science Club and really as in this program, you sometimes deal with huge data sets, right? And so I need my RAM because R, if you didn't know, R shoves everything that it has to into RAM. And if you run out of RAM, well, I'll tell you a little bit about what happens when you run out of RAM. Because for me, it wasn't fun. The second type of crash. The second type of crash is a screen crash. Basically it means that the screen is still there. You can see everything. By the way, this is what R looks like. I'm sorry, yeah. I know you haven't seen it before. But basically, and it's only like half of the screen. But the screen shows up. However, you can't do anything, right? I think I've already talked about that. That red button doesn't do anything. Or sometimes that red button shows up with that dialog box which just says terminate R. What are you going to do, right? So do I say yes? Do I say no? What am I going to do? And what you should do is make sure it's still working. That's what you should do. Just make sure it's still working. So I'm going to show you a little bit of math about how and what I'd use to basically determine if it's still working. So if you're familiar, this thing on the right is called Task Manager, right? And then basically what I'm doing is figuring out how many, and Windows calls it logical processors. Some people call it threads and some people call it cores. I'm not going to be nitpicky about that. Basically, it's how many threads, I use threads, how many threads you have in your computer that it can process out of. So you divide 100% by how many? I have 12, so I'm looking for about 8%, right? Everybody's a little different, right? Especially if you have a laptop, it probably has 4 or 6, right? Who knows, right? You gotta look at yourself, you have to do this on your own. I cannot help you with that. You divide it by, and then you figure out what percentage it pops out to be. Because then, when you look at your task manager, and you look at your RStudio, which you look in the middle, it should be about that, right? If it's running, if you are in the screen crash mode, and it's still running, it should be about that, minimum, because there are functions that use multiple cores or multiple threads and other things like that. So its minimum uses 1 thread, right? So, now that I've determined that it's still running, because if it's not running, I don't care, then close it, right? It's done, right? These are my 2 options. Normally, because school, right? They give you nice data sets, small data sets, and I don't really have to worry about them. I just close it and retry. But there has been a time where the workload was worth it for me. I loved it. I wanted it to keep going. So really, these are the types of things you got to consider, right? Maybe I infinite looped somewhere. Maybe instead of trying to figure out how long it's going to take, maybe I can batch it up into multiple pieces, right? Because I don't want to do it in one go. I don't have that kind of time, right? Let's see if I can spread the workload out somewhere. I can do it overnight while I'm sleeping, blah, 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 right? One thing that I recommend is that because you still have access to your code, I realized one of my, I've just been waving my hand around here with this. Okay, one thing that I noticed is that if you can still access your code, so save your code, because sometimes it doesn't save correctly. Save your code and put it on the back, right? Save it, because sometimes if it crashes, it won't save whatever you're doing, right? And then just close it and try again, right? Or batch it and retry, right? This is what happened. Now you're gonna see, you see that nice little picture. I'm gonna come back to it a couple times, because this is a lovely little mistake that I made. I was curious. I had this wonderful idea where I had batched something 4 times. I had 4 batches, right? And I ran 2. I wanted to run all 4 because I wanted to run all 4 of my cores. I had 12 cores, 12 threads, right? I wanted to run all 4 of them. I ran 2, and then I ran out of memory. Okay, great. But on one of them, I said, hey, I'm going to put in a little write statement. So even if it crashes, it'll try to write out into an Excel file, and I'll have it. Don't do that. Don't do that. Because if writing out to CSV takes a long time, depending on how big your file is, right? If it's a small thing, okay, no problem. I'll show you how to do it a little bit later. This took 4 hours. I let it go. I had 4 of them. I ran 2 at the same time because I ran out of memory. And I had to write.csv on one of them, and I left the other one going. I ran all 3 of the other ones. So I ran all 3 of the other ones in the time it took just to write this file out. And more, there was more time. I literally just left it at that point. And you can see it wrote 12 gigs. That's 12 gigs of space. Not a good idea. Don't do that. Don't do that. So, really, what I'm saying is from a screen crash, you can recover from it because it will still run. It's still running in the background. The question is, do you care? Is the workload worth it? Can you find another way to do it, right? Because most of the time, especially when I first started, I didn't care. Close it, try again, right? But if the workload, because at some point the workload's going to be good. It's going to be something you really want. And at some point I've let the workloads run for 2 hours, and then it crashed. It either screen crashed or regularly crashed. So I'm sitting there and I'm like, what am I going to do? Do I wait for it? Do I really want the workload? Or do I just try again and waste another 2 hours, right? What is your time, right? So yes, it's not really as required when you first start out, but when you really start with big data sets, you really start to have to consider what to do next, right? And how am I going to tackle this big problem, right? Because all of a sudden everything is multiplied. So let's go to the third one, the white Christmas, the lovely of the ones. Basically everything's white. Looks like that. Nothing but this, or this. By the way, the middle one, the R session aborted, actually means you're SOL. You're done. Like, there's nothing you can do. You literally just hit start new session and it restarts. You cannot do anything. It means you've completely died. When it's actually a white screen though, I'd like to tell you a little story about this one. Because I actually ran out of memory. Remember I told you those 4? I had those 4? I didn't know I could only do 4. I didn't know that because I figured, I have 4 threads, right? I'm going to run all 4 concurrently. at the same time, right? I'm going to do it all at the same time. It's going to get done quicker. Great. I ran all 4 of them, and then it felt like, basically it felt like I got hacked, right? Like in the movies, right? What had happened was I had my screens in front of me, and then, boom, black, 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 completely gone. I went, what? And then I was expecting like a skull to come up and be like, ha 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 ha, we've taken over your machine. And it hasn't happened, didn't happen. Everything went black. And then I was expecting my machine to restart. Because usually if it crashes, right? Usually when your monitors go blank, your machine, with my machine's underneath me, my machine would restart. But I used to work in tech support, so I'm listening for it. Because I can hear it restart. I know when it restarts. And it makes a very specific whir. Nothing. It's still on. It's still working. What? It hasn't crashed, really. I mean, it crashed, obviously, but the machine hasn't restarted. So we're probably still in Windows. Okay. So I turn off my monitors. The first thing you do is you remember the old joke, you turn it off, you turn it back on again, right? So I turn off the monitors and I turn them back on, nothing. Still black screen everywhere, right? I'm still hacked, basically. I'm like, what am I going to do? So I was like, well, the only other thing I can do without actually restarting my machine is I can reinitialize the monitor, which means that I can unplug it out, plug the monitor, and plug it back in, right? Because then it'll send a signal to the Windows machine and reallocate memory, right? So I did that, and then my monitors came, or one monitor came back, the one I unplugged and back in, and then I got this lovely picture. Now if you see this picture, if you look really closely, the left picture is RStudio, white screen, crash, Christmas, gone. And then I figured, what's actually running? Nothing. Look at that. This is Task Manager. It means this is all the things that are supposed to be running on Windows. I've crashed Task Manager. It's gone. Nothing you can do. At this point, there's nothing you can do. I'm done. I ran out of memory. It broke my whole system. My graphics card basically said, no, I don't want to show you anything anymore. And then boom, dead. At this point, you close and you restart. You try to figure it out what happened. I crashed again because I had to figure out what actually happened. The first time it happened, you have no idea what happened or why it happened. I watched my memory and I just watched it go up, 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 up. It hit my limit, which is minus 32 gigs. It hit 32 gigs, boom. Pirates again, right? Everything went black, everything is gone, right? Oh my goodness. So that's how I found out, that's the hard way I found out I could only run 2 at a time. Yes, it's the only way I found out I could run 2 at a time. Just restart and close it. If you run out of memory, sometimes bad things happen. So some things you just, and your mileage may vary because all the machines are different. You have different software on your machine. It can crash in different ways, right? That's how happened to me. If it happens to you, you know what to do. Although if you have a laptop, I'm not sure how you're going to unplug the screen and plug the screen back in. You really can't. I mean, there is a way, but it's very difficult. Okay. The only way to really fix any of these crashes is by pre-planning, unfortunately. Remember I told you don't write out your CSV? Don't do that. Please don't do that. Because then, that's why I'm reminding you from the lower right, 12 gigs took me 4 hours. Kid you not. Took me 4 hours. I let it go because I was just curious. I just had it go on the side. I was like, when is it actually going to finish? And it finished. These are the ways you can save and load objects into R, right? The first function is load, which means I'm pulling it in. Save is just save. You can specify what objects to save. The save image is basically like a save all. Save your whole environment, right? And then save RDS and read RDS. Those things are special. Again, these are all functions, and everything that goes in it is really just like what you want, right? These are serialized forms. The one thing that people like about save RDS and read RDS, one thing is that it's only good for one object. One object. You can only save one. Now, why do you care? Well, remember that 12 gig file? How big do you actually think that 12 gig file was in RStudio? It's almost as big, right? I can't load everything else into my memory with just that, right? So I'm going to pull just that file out and I'm going to save it separately so that when I load it in and I redo my analysis on it, I can continue. I can do everything else with it. But I wouldn't have to have everything else in my environment, right? It allows you to really just pick and choose what you want, right? And also you can save it into different names. RDS just kind of takes away your name. So if you named your object cat, if you use the load or save, the first 3, it loads it back in as cat. If you use the save RDS, it has no idea what the name you saved it in. So when you put it back in, you can name it kitten. You can name it cat2. You can name it cat the better, right? It doesn't matter. So I don't know. People seem to like that feature. I don't know. I couldn't tell you. The other functions that are also really useful is remove, which is the RM. Again, it's to remove objects in your environment. And then the list is a function inside of, well, not function. It's a I don't know I can't figure out the name of it. It is something that you use inside RM, and it's equals ls. Now ls is basically list. It's listing everything in your environment. That's what it does. So that function together removes everything in your environment. Because sometimes you just need to clear it out. You've done your pre-processing, and I don't care about anything else that I've done for pre-processing. So now I'm just going to load in the important bits and then continue my analysis. Because I don't have enough memory to handle all this stuff, right? A lot of it's about memory management in R, because you can only you can put only everything in R. You can only put everything in R, right? Only put everything in memory, because it requires everything to be in there. That was a really roundabout way of saying that. Okay, and then there's GC. GC is just garbage cleanup again. It removes everything that's really, it actually removes everything. Because the RM removes it from the global environment, but it doesn't actually, it may not actually remove it from, well, it may not actually remove it from R, right? It still might be there. Because I've sat there and I've looked at it and I'm like, I still don't have any space left. And it's like, I don't have any memory left. What am I going to do? And so you run GC, and then all of a sudden 12 gigs comes and appears, right? Because it actually got rid of that file, even though you've removed it already. Okay. don't write to CSV. I write to CSV if it's small, right? If you actually need it in CSV format, write to CSV. Do it as a, I need an output. Don't do it as a, I need to load, save and load. Don't do that. Because I uploaded the same file, the 12 gig file, into a save and load, and it took like 3-4 minutes, as opposed to 4 hours. It seriously, I sat there and I was like, why am I doing this? This is bad. This is a really bad idea. I'm going to tell you a little story about how I lit my almost lit my computer on fire. Now, I'm going to give you a little bit of context. Your computer should not increase beyond 90 degrees Celsius. I had this wonderful idea where I batched a bunch of things. I can show. I actually have code for how I batch things, but I batched 100. I had 105 batches, and I have 12 threads. Right? You do the math. I can do 12 if I really wanted to, but I want to use my computer a little bit. So I use 11 threads. So I have like basically one core, right? I'm just like chugging along with one core or one thread really, right? To do everything else, operating system, right? Chat, whatever, everything else, right? I ran 1, 2, 3, 4, holy, at 5. My machine, luckily I had these things that I'm going to tell you about. My machine hit 100 degrees Celsius. Celsius means that I can boil water because it's about 212 degrees Fahrenheit. You do not want to be there. You do not want to be there. I found out very quickly that my computer was not thermally stable. I was shutting down stuff. I would have pulled the plug out of my machine because it will significantly degrade the life of your computer. Very significantly. And maybe the processor might be able to take it, but the other things around it might not be able to take it, right? Your motherboard might die. There are other components that might just, right, because of the heat. What I learned, or what I really am telling you about, is you should get temperature monitoring software. You should benchmark your machine. Because if your computer is not thermally stable, how are you going to run a neural net? How are you going to be able to do all these lovely things that we're teaching you, or that you're going to be able to apply all these things to a Kaggle data set? You don't want to find out when you're doing it, or when you're actually trying to process everything, that you can't do it. So you should do these things. There's words of warning though. This is what I use. I'm sorry I don't have a Mac, but I've heard Geek Tools equivalent. What I do is something called Rainmeter. It has a gadget, which is, this is kind of weird. Rainmeter is the program overall, right? Modern Gadget is sort of like an add-in of the program, and then Hardware Info uses, it basically takes all the information from all the sensors, right? And it looks like that on the right, on my right, or your left, right, whatever. So it's a little bit hard and cumbersome to set up. I have a link in the last slide to show you a little bit about how to do it if you really want to do it. As you can see, I finally got it stable, right? This is 100% all cores, all my 12 cores. We're at about 54 degrees Celsius. I'm comfortable. I'm okay. At some point, I watched it. I seriously saw it. I was screaming at the computer. This is why you have no pictures of it, because I was just screaming at my computer. I was like, no, please be stable, please, please. And then it wasn't, and I had to shut everything down. So this is what I use. I have linked to Modern Gadgets. There are other ways to do it, and there's tons of temperature monitoring things. You should make sure that the temperature of your computer is good. Why else should you do that? Well, because ultimately, if your temperature reaches too high, your computer will naturally slow down, just naturally. It's a temperature regulation thing for computers. So if you want to run at maximum speed, make sure that you're running as cool as possible. That's really what it comes down to, right? Well, so I have to warn you that benchmarking is very stressful to your computer, very stressful. Right? You could potentially break your computer because you're pushing it to its limit, right? Ultimately. I mean, that's also technically what you're doing. You're also pushing it when you run a neural net, or you're trying to train a neural net, or you're doing other things. I'm running SVMs or whatever it is, right? When you're doing all other machine learning type things, you're also pushing your machine. So you might as well find out now that it's not going to work, and then you can figure out what you're going to do later. I've seen people with box fans. You put a box fan. It's literally a box, or it's a giant fan. You put your laptop on top. And I know a laptop's not the ideal, but I know a lot of people have laptops here. So you put a laptop on top, and then you just let it, you let it cool your computer. As long as it's cool, it'll be okay, generally. You have to make sure you have good airflow. This is more for the laptop people. Make sure you lift it up, prop it up, make sure it's cool. That's why you should always have temperature monitoring, because at some point you might melt things on your computer, and that's not going to be good, right? Either that, or you're just going to have less performance, right? Hey, I want to get home just like everybody else, right? So if I'm running and I'm doing something, I want as much performance as I can get out of my machine, right? These are some of the tools that I use for CPU stress testing. R uses the CPU. I think there's some things that also use GPU. I know Python uses GPU, so there's some, I added in a GPU stress test, although it's more of a graphical thing and not necessarily, it's more stressing on a graphical thing. So Prime 95 firmware, I don't suggest you use Intel burn test because it's almost too strong, but you can do it if you'd like. My computer is not actually stable with Intel burn test, as terrible as it is. It is stable with the other two, it's not stable with Intel burn test. It will get a little too hot. And everything I was talking about in terms of slowing your computer down is called thermal throttle, ultimately, right? It means that it's going to slow your computer down because your heat is too high, right? That's really what it comes down to. I want the best performance, right? Here's some cool links as to what and why. Stringus factors, if you happen to want to know more about it, because, well, I remember crying a bunch because I couldn't get factors to work correctly. I was like, it's a number. Why can't I just throw it in and make it a number? I couldn't do it. There was a lot of trouble. I had a lot of trouble with it. But that, again, pre-processing is a good idea. And then if you've ever used Excel a lot, right, there's a first link. The first link is basically, hey, what is the equivalent function in R for Excel, right? So if it can help you associate things and all that sort of thing. That's the Rainmeter guide, and here's some data sets. Thank you very much for your time. Actually, I think that there was one more function. I don't remember what it was. I can't remember. I think it was like object size or something like that. And that's what I'm looking for right now. But there's another function that you might want to know, because I didn't know how to actually look at how big a object is. Didn't know. So there's a function which I don't remember what it is. I think it's object size. I could be wrong. But basically it tells you how big that object is, so if you're going to try to write it out, you have some idea as to how you would do it and why you would do it and in what format you want to put it in. Because if it's too big, you can't do anything, right? Or you have to figure out alternative ways. Thank you very much. That's pretty much it. I can go to a demo now, but I have a sort of a little bit of a demo prepared, but I think we might save that for another time or whatnot. But yeah, thank you very much for your time. Any questions?